get us to your first lesson in Chapter 2. We are starting on page 84 in your textbook, and this is I can express rational numbers as decimals and decimals as fractions. This is kind of a vocab-rich chapter on words that you're going to want to know what they mean, starting with rational numbers. You should know what decimals are, but we are going to cover different forms of what decimals look like. And then you should know what fractions are as well, but we'll talk about the different parts of a fraction. So have some notebook paper out, get ready to take some notes, and jot down some words that I tell you and that you think are important. So, rational numbers. Numbers that can be written as fractions are called rational numbers. It's pretty much simple as that. If a number can be written as a fraction, something that looks like a over b when b is not 0, you can't put a number over 0. It does not work out. If a number can be written as fraction, you can consider it a rational number. Right now, we're just talking about rational. Some of you may be thinking, well, aren't all numbers rational numbers? Can I do everything as a fraction? No, you can't. And later on, you'll learn about irrational numbers. Those would be numbers you can't write as fractions. But today, we're going to focus on rational, things that can be written as a fraction. There are a number of different categories numbers can go into, and they start with, today we'll start with looking at being rational. Again, rational numbers can be written as fraction. This 8/10 can be written as 8 over 10 or 4 over 5, so it is rational. 5 and 2/10 repeating can be written as a fraction. Negative 1 and 4/10 repeating. 5 and 2/3 is a fraction. 1/2 is a fraction. Those all can be written as fractions. Decimals can be written as fractions, so they're rational. Other numbers are like integers. Those are my positives and negatives. We've seen those. We've worked with those. They're rational numbers because I can also write them as a fraction, but they're integers as well because they're negative or positive. Whole numbers are both rational numbers, integers, and whole numbers. They can be written as fractions, 26 over 2 or 13 over 1. So they are considered rational. They're positive numbers, so they're integers. And since they are positive, they're also whole numbers. Any fraction, positive or negative, can be expressed as a decimal by dividing the numerator by the denominator. Hopefully we know on a fraction, the numerator goes on top and the denominator goes on bottom. A trick I learned, luckily, and a trick for you that could help, is your teacher, me, is from North Dakota. So you can kind of remember numerator on top, denominator on bottom. Some people remember it as north is up, down is down, so top and then bottom. Hopefully that helps with those things. But we're saying that we can write this fraction 5/8 as a decimal because that fraction bar is really also a division sign. So we can really just do 5 divided by 8. So if I do, first number goes into the division, and 8 is trying to get into it. On a whole number, the decimal is behind, so then we can put it there. 8 does not go into 5 any full time, so it goes in 0, and I fill in with another 0. 8 goes into 50 6 times. 6 times 8 is 48, with 2 remaining. Since there's 2 remaining, I'm not just writing remainder 2. I'm actually going to find out what part fits in. Fill in a 0, bring it down. 8 goes into 20. 8 goes into 20 2 times for 16. Bring down the 4. Still remainder, so we're going to try to get rid of it. 8 goes into 40 5 times. None remaining. So what this means is 5/8 can be represented and is the same as 625 thousandths. So those can be the same. So we can divide this fraction to look like a decimal. I'll give these a try. I'm kind of talking fast just because I know that you don't want the video to go super long, and you can pause me. So anytime it's a little rushed, put me in slow motion or pause me and we'll have no problem. So I'm going to try these 3. You can pause me and try them on your own or whatever works best for you. So 3/4 I know is the same as, how many times does 4 go into 3? 4 doesn't go into 3 at all, but it does go into 30. 7 times for 28. And then I still have a little bit more, so bring down my 0. And then 4 goes into 25 times with no remainders. So what this means is 3/4 is the same as 75/100. Since this is negative 3/5, I know that my answer is going to be a negative, because we know negative divided by a positive is a negative. So I'm going to do negative 3. How many times does 5 go in? Put my negative up there right away, and just kind of ignore it for now. 5 does not go into 3, but it does go into 30 6 times exactly. So it's as simple as negative 6/10 is the same as negative 3/5. Here, since I have 4 and 13/25, I know that in decimals, my whole numbers are to the left of the decimal, and my parts of wholes are to the right of the decimal. So I have 4 whole and then 13/25 as a part of a whole, so I have to find out that fraction. So 13 divided by 25 goes in there no times, but it goes into 130 5 times, and I know that because 4 times 25 is 100, and I know another one fits. So I subtract with 5 left over. It doesn't fit in there, and I can pull a new place in. 25 goes into 52 times for exactly that many. So what this means is 4 and 13/25 is the same as 4 and 52/100. Every rational number can be written as either a terminating or repeating decimal. A decimal like 6 and 25 thousandths is called a terminating decimal because the division ends or terminates, which means stops, with a remainder of 0. So here's another one of those vocab things which I am probably going to ask you about, and you'll have your vocab sheet. Terminating decimal means it stops. So right here we see that there's no more remainders after the 5. So that decimal does not continue, it stops there, terminates. Other type of decimals are repeating. If the division does not end, a pattern of digits repeats. Repeating decimals have a pattern in their digits that repeats without end. Instead of the 3 dots, because those are sometimes used to show that the decimal goes on and on, without repeating, instead of the 3 dots, we're going to use bar notation. Bar notation is used to indicate a repeating decimal. So bar notation indicates a repeating decimal. So here we see the 3, and it's just repeating on. So we can really just write that as 3/10 repeating with that bar notation. Negative 28/100, the 2 and the 8 repeat, so it's negative 28/100 repeating. And here, if you notice, we have 60 and 7, 115 thousandths, but the 7 doesn't repeat, only the 15 does. So the bar notation only goes over the 1 and the 5. All right, so here, same thing. I can write a repeating decimal. Once I realize that it's not stopping, it's going to repeat. I can just do the same thing. So I have negative 1. I know that's there. And I have to find how many times 3 goes into 2. 0 times. 3 goes into 20, though. 6 times for 18. And I subtract to get a remainder of 2. Hopefully you notice a pattern. Well, I already have that 20. Goes there 6 times. I'm never going to get out of this cycle of that 3 only goes into 20 6 times. So I'm going to continue to get those 6's there. It's going to go on and on and on. So I can shorten that up by writing that as 0.6, and that 6 is going to repeat. So negative 1 and 6/10 repeating is the same as negative 1 and 2/3. You can give these a try. Pause me if you need to, and then come back. Okay, so we have 7/12. We want to find out what 7/12 is as a decimal. So I can do 7. I'm looking for how many times 12 goes in. Put my decimal in. 12 does not go into 7, but it does go into 70. I'm going to give you a chance to figure that out. How many times does 12 go into 70? Well, I know that 12 goes into 65 times. I know it can't go in there again. So I'm going to put a 5 and subtract 60. And there's 10 left over. Well, 12 does not go into 10, so I'm going to bring down a 0. And I know 12 goes into 100 8 times for 96. And I subtract and I get 4. 12 doesn't go into 4, so I bring in another 0. I do know that 12 goes into 36 3 times, so that's a little less. And then I notice I'm going to keep getting now those 4s. So what number is going to repeat is that 3. So 7 twelfths is the same as 583 with a 3 thousandths repeating. Going on, right away I see that negative, so I know my answer should be a negative decimal. I'm going to find out how many times 9 goes into 2. 9 goes into 20 2 times for 18. Notice again, we're going to end up with those repeating 20s. Well, we know 9 can only go into 20 2 times, so we keep getting this pattern when our remainder continues to be the same. Then we're going to end up keep having that. So this is really negative 2/10 repeated. 3 and 1/11. I know 3 is a whole number, so I know it's going to be 3 and something. So I'm just looking for how many times 11 can go into 1. What part of 11 is 1? So it goes into none. 11 does not go into 10, but 11 does go into 100 9 times for 99 with 1 remaining. Again, we see, well, it can't go into 10, so we put the 0 up. It can go into 100 9 times, and we're going to end up with that pattern of getting that remainder of 1. So we see that we're going to end up with this 0 9. So 3 and 1/11 is the same as 9 hundredths repeating. All right, some things here when you're having real world situations. This is when you'll see decimals. The New York Yankees shortstop Derek Jeter had 6 hits in 22 bats. This is kind of like how many you get right out of how many you attempt, like on a quiz. And you're going to round to the nearest thousandth to find his batting average. So what they do here is first you're going to find the average by dividing the hits by the number of at-bats. Kind of like you take a quiz out of 30 and you get 20 out of 30, you would divide 20 by 30 to find out your score. So we would divide 6 by 22, and on your calculator you would see 27 hundredths repeating. So you're going to look, because we're rounding to the thousandths place, you're going to look to the place to the right of that. So here's the thousandths. So I look 1 over at 7. Since 7 is greater than 5, I round up. And that 2 should become a 3. And his batting average was 273 thousandths. Here's a word problem for you to try. In a recent season, NASCAR driver Jimmy Johnson won 6 out of 36 total races. To the round to the near thousandths to find the fraction he won. So we're looking for 6 out of 36. So what you want to do is divide 6 divided by 36 and see what you get. And you can do that on your paper or not. And you're going to end up with, let's flick for a while. It says you can use your calculator, so not 1. 0 and 1, and then there's a few 6s going on here for a little bit, and way at the end there's a 7. So I look to my thousandths place, and 1 over, since that 6 is greater than 5, I'm going to round up, and I should find out that he won 167 thousandths of his races. Terminating and repeating decimals are also rational numbers. Okay, so decimals, because we can write them as fractions, so that's what you got to think about. We've seen that we can write those decimals as fractions and the repeating decimals as fractions. So because of that, they are 2 rational numbers. So if we want to write 45 hundredths as a fraction, what you can see is, I like to say, write it how you read it. because you read this as 45 hundredths because it's in the hundredths place. So that's really just the same as 45 over 100. You can write it like that. If I were to ask you to simplify it, what you'd have to do is find a common factor. In this case, they both share 5. So you can divide both by 5, and 9/20ths is its simplified version. A lot of vocab, remember. So when you give these few a try, and you can just write them like you read them. So this first one I read as negative 14 hundredths. So I write negative 14 over 100. I see that they're both even, so I know that they have a common factor of 2. 2 goes into 14 7 times, and it goes in 100 50 times. So this is the simplified negative 14 hundredths. 8's a whole number, so I know that's on the outside. 75 hundredths is like this. A number that goes both into 75 and 100. They both can be changed, so I know both 25 goes into both. So I know 25 goes into 75 3 times, and it goes in 100 4 times. Okay? When it's repeating, this one's a little tricky, and this is kind of in your book. If you look at example 5 in your book on page 86, that's going to help you with this one. So I want you to kind of go through that one, and we're going to jump through it on our, just wrap up the video. We'll jump through those ones tomorrow in class because I don't want this to go much longer. So look at those and show me. We're going to do this in class. Wahoo! Okay? So remember what you can do. Rewatch, pause. I know it was quick, but it's definitely going to be worth it. Keep up with that vocab.